Okay, as promised, this is another example of probability. This time I'm going to show you how to use the two-way table. 100% honesty here. I've just started getting comfortable with these. Before, I was always someone who worked with Venn diagrams. Now, I'll be honest, I've gotten a lot more comfortable with tables, so I love sharing this because I think it's a great strategy. We're looking at the same problem where we have 56% of all American workers having a workplace retirement plan, 68% having health insurance, and 49% having benefits. And we're looking at selecting people at random and getting a probability. So what I'm going to do is I'm going to fill in what I know based on what I've read in the problem here. And I notice I made a table. This is where some people even struggle. I'm dealing with two variables here. I'm dealing with health insurance. I'm dealing with retirement. And either one would be yes and no. So I'm going to fill in what I know. Now, since this is based on percentages, I'm going to fill in my marginal distributions, which are nice and easy because I know they always have to add up to 100. My whole sample space should add up to 100%. So that's nice and easy. It's telling me 56% of all American workers have a workplace retirement plan. So I'm going to look for is my retirement plan here. Notice I have Y here. This is all the people who have it, the yeses. They should total up to 56%. I also know that 68% have health insurance. So if I go to the health insurance right here, straight down for Y, go down to the bottom, I'm going to plop in my 68. And here's what I like. It gives me a chance to work backwards a little bit. I have one more I can fill in as well. It says 49% have both benefits. Now, if they have both, I'm going to look for my yes, yes box. And that they, yes, have health insurance, and yes, they have retirement. And I'm going to plug that in as 49. I'll get rid of all this highlighting I've just done. So now the thing about a table is this allows us to kind of just, you work backwards a little bit. It can be a lot of fun. So I know I have 68 here. I have 49 here. In order to get the no's here, all I have to do is I have to subtract 49 from 68. And I get 49 minus 60, or 68 minus 49. There we go. And I get 19. So it tells me 19% of people have health insurance, but no retirement. I can also go over here. I notice that 56 minus 49 gives me 7. So it tells me that 7% of people have retirement, but no health. I can also take 56 away from 100. That gives me the 44% of people who have no retirement. I could also do 100 minus 68, which gives me 32. And now I know this is 32 and I know this is 7. I could just do 32 minus 7. That gives me 25. And this should all check out now because if I add 19 and 25, I get 44. If I do 7 plus 25, I get 32. If I do 68 plus 32, I get 100. 56 plus 44 gives me 100. 49 plus 7 gives me 56. 49 plus 19 gives me 68. So that's the cool thing about using a table. You're able to kind of plug in what you know. Then you can work your way backwards just using addition and subtraction. Some people this is easier for. Some people prefer that Venn diagram. Once you get the hang of these tables, though, they can be nice tools to work with. So what I'm going to do now is I'm going to just shrink this down so I can answer some questions based on what I'm seeing in the table. Now it says he has either employee-sponsored health insurance or retirement plan. So let's see. That's going to be either. So what I can do is I can look at those who have a retirement plan, which I have is 56. I have those who have health insurance, which is 68, which I'm going to add these up. It's wonking out on me. That's okay. I can make it work. I'm going to notice something. I'm getting a big number here. I'm getting 124. Wait a second. That number seems really large. Why is that happening? Maybe you know, maybe you don't. So now you're looking 124. What's going on here? Here's the problem. And this happens. This is why it's good to know what you're doing. I'm going to use a different highlighter here. When I did that 56, I did all these people to get my 56. When I did my 68, I did all these people. Wait a second. You probably noticed I used something twice. Every time I did that, I did these people. And then I'll use another color. These people. Hey, 49 got colored twice. I'm using them both times. Why? Because he answered yes both times. So if I take away 49, that'll give me my final answer here of, let me do some quick math. That will give me, why am I drawing blanks here? Hey, 75. Cool, that works. And the other way I could get there is I could just take away out all the people who have neither, which is that 25. It gives me the same answer. 25, take away 25 from 100. That works too. Cool. So I've just answered A. Now, part B says, I'm going to get rid of all this highlighting and stuff. Gets a little messy, right? Now, for part B, it says he has health insurance if he has a retirement plan. So let's take a look at those. If they have a retirement plan, that's going to be 56 out of 56. Probability of having health if they have a retirement. It's going to be out of 56. All those people have retirement. And within that 56, 49 have a health plan. If I turn that into a decimal, it gives me 0.875. I know that from the previous video. I'm not just a mathematical genius. All right, now part C. This is where people get tripped up and they have to talk about independence, but don't worry, we can do this. Now for the independence aspect, right? Let's take a look. There are a couple ways we can prove this. We can do the probability. We can actually even use the answer we just did here. The probability of having health insurance, right, is, look, everyone who has health insurance, that's 68 out of 100, 0.68. Now, if having health insurance and a retirement plan are independent events, what we'd expect is that the probability of having health insurance, if you have a retirement plan, is not going to change. We should still be seeing the same ratio. We are not, however. All of a sudden, when we throw a retirement plan in there, when it's health insurance giving you a retirement plan, we're getting a different probability here. We're getting something higher. That's telling me I'm more likely to have health insurance if I have a retirement plan. There's a relationship going on there, which means these events are not independent. There's another way you can do it as well. You can do the probability of having health insurance times the probability of having a retirement should equal the probability of having health and retirement. Probability of having health and retirement, the both, is 49 out of 100. It's 0.49. Probability of having health insurance, we've determined, is 0.68. Probability of having retirement is 0.56. We multiply them out. I guarantee you're not going to get 0.49. Let's see what happens. 0.68 times 0.56, which I've already done. I got 0.38. Oh, 8, which does not equal 49%. If they are independent, the probability of them happening at the same time would be the same probability as multiplying the probability of one times the probability of the other. So I've just proven they aren't independent. So that's how you can use a table to help you out with problems like this. Again, some people love tables. Some people love going with whatchamacallit? Venn diagrams. Whatever helps you, that's ultimately what counts. So go with whatever process you think helps.